Okay, so we're going to start assignment number 5 today, which is descriptive measures for populations and standardizing those descriptive measures. So let's go ahead and get started with this. But first, we're going to review. And so we started with 3.1, which was measures of center. Then we did measures of variation. Measures of center are mean, median, and mode. And then measures of variation are the range and also the standard deviation. We talked about Chebyshev's rule and the empirical rule, which talk about the number of data points or the observations that are within certain standard deviations from the mean. And then the 5-number summary and box plots, as well as outliers in 3.4, which could be used for any set of quantitative data. And then today, 3.5, descriptive measures for populations and the use of samples. So let's go ahead and get started talking about that. First, just a real quick definition. The population mean, we've talked about the mean before, but the population mean, we're going to call it mu, is how you say this. Mu of x would be the population mean for any variable x. But we would find the average by adding up all the certain specific observations and dividing it by the total. And so just real quickly, if we look at Augusta National Golf Course, which is a famous golf course in Georgia, you have 18 holes, and each of the holes has a name and a length in yards and what the par would be. But if we were to take all of these lengths of the yards at Augusta National and average them together, that means we would add them all up individually, 445 plus 575 plus 350, add them all together, and then divide by 18 holes because there are 18 of them. We would get the average is 413.3. That's what is designated by mu. We're going to use that later on here. So whenever you see mu, we're talking about the average, okay, or the mean. And so population standard deviation, we've talked about this before. We said that the sample standard deviation is denoted with an S, and that the population standard deviation is this sigma. And these are the two formulas that we came up with, I think is assignment number 2, to find the standard deviation. Of course, we don't need to know those formulas. I just wanted you to know that they were there because we can find the standard deviation on our calculator. So we could find the standard deviation of the holes on the Augusta golf course, and we would find that it would be 132 yards. So that means the average golf hole in the Augusta National Golf Course is 132 yards away from the average, which was 413.3 yards. Okay, so let's, this is just a visual so you can see the difference between what the sample data would be, a sample mean and a sample standard deviation, and then what the population standard deviation would be and the population mean. So if it is a statistic, that is a descriptive measure of a sample. If it's a descriptive measure of an entire population, most of the time it's called a parameter, okay? A lot of times they use statistics for either one, but if it's a parameter, it's based on a population. A statistic is based on a sample. And so what we want to do next is we're going to standardize the standard deviation with any data set. And the standardized number is called a z-score. So z-scores are very much related to the standard deviation. I want to show you first how it is. So for example, we have any set of data here. We have the mean, which in this case is at 0. We have the 1 here signifies that it's 1 standard deviation above the mean. The 2 signifies that it's 2 standard deviations above the mean, and the 3 signifies that it's 3 standard deviations above the mean. Those are z-scores. If we're talking about the specific values on Augusta National, the specific mean is 413.3. That's the actual average. But the z-score for that average would be 0. The actual value that is 1 standard deviation above the mean would be the 413 plus a standard deviation, which is 132, that's going to be 545.3. So 545.3, that number has a z-score of 1. If I go 2 standard deviations above the mean, which means I add 132 again, I'm going to be at 677.3, which means 677.3 has a z-score of 2 simply because it is 2 standard deviations above the mean. We can do the same thing with 3 standard deviations above the mean. If I add 132 again, I'd be at 809.3. That has a z-score of 3. I can go in the other direction. A z-score of -1 would be 1 standard deviation below the mean. So in other words, if I took 413.3 and I subtracted 132, I would get 281.3. Well, that number has a z-score of -1. If I subtracted 132 again, I'd be at 149.3. And that number would have a z-score of -2. And finally, if I did it one more time, if I subtracted 132 from 149.3, I'd be at 17.3. That has a z-score of -3. Okay? But here's a formula that, man, you really need to put this in your notes, because this is how we find the z-score for any value. We can find the z-score by looking at a table and just adding the standard deviation to find the specific z-scores that are exactly at 1 and exactly at 2 and exactly at 3. Well, how would we find the z-score for something like, let's do this right here, hole number 1. If it has a distance of 445, 445 is going to be about right here. It's going to have a z-score somewhere between 0 and 1, but what is that z-score going to be? Well, in order to figure out what that z-score is, we're going to use this formula. We're going to take the actual observation, which in this case is, what was that again? 445. We're going to take 445, and we're going to subtract the average, which was 413.3. And then we're going to divide that by the standard deviation, which is 132. And so I'm going to take out my calculator. I'm going to take 445 minus 413.3, and I'm going to divide that by 132. That gives me an answer of 0.24. That means that a score that is actually 445 yards, a hole that's 445 yards, would have a z-score of 0.24, which means it's 0.24 standard deviations above the mean. And so this is the formula that we're going to be using to find z-scores. Z-scores that are positive are above the average, z-scores that are negative are below the average. And so that's what 4.5 is about. And there is a homework assignment on this in Math Excel, and we will go over it tomorrow. Good luck. We will see you then.